Hi everyone. So in this pre-lecture tutorial we're going to pick up where we left off in the last pre-lecture tutorial. In the last tutorial we were talking about how to write formulas for individual ions. And now this time what we're going to do is we're going to actually start to put those ions together to form compounds. Now the compounds that we'll begin studying now are actually somewhat simple. They're called binary compounds, and basically by binary we mean that they're made up of two ions. So if I can figure out what the formula for each ion is, and I can put it together while at the same time balancing the charges from each ion so that the overall compound is neutral, then I'll end up with the formula of the compound. So let's get right into it. I have a list of compounds that we're going to be working with here today. Now we're not going to do all of these, but we'll do some. And obviously I'll leave some for you to do as a follow-up assignment. And hopefully between this demonstration and also your working with the follow-up assignment, then this will make a whole lot more sense. And when we come into class tomorrow, then we'll have a better point from which to begin working with the material in this section of the chapter. So take, for example, this first compound here, magnesium nitride. Okay, so if you recall from the last tutorial, if I'm going to write out the formula for the magnesium ion, then I should find it in the periodic table. Okay, there's magnesium, and I should locate its nearest noble gas. Now, its nearest noble gas is neon. Okay, now, if you recall our rules for finding the number of valence electrons for main group elements, since magnesium is in group 2, then that means that magnesium has 2 valence electrons. And in order to get an octet of electrons, because neon is in group 8, so that means neon has 8 valence electrons, then if magnesium loses its 2 valence electrons, then it'll end up with the same configuration of 8 valence electrons that neon has. And so as a result, that means magnesium will lose these 2 valence electrons and become a positive ion, or a cation. So that means that my first ion is magnesium 2+. So this should be magnesium 2+. Now, if I want to write the formula for the nitride ion, here's nitrogen. Okay, now its nearest noble gas also happens to be neon. Based on our rules from the last tutorial, since nitrogen is in group 15, that means it has 5 valence electrons. To get the 8 valence electrons that neon has, then basically it would have to gain 3 more valence electrons. Since it's gaining electrons and electrons are negatively charged, then that means nitrogen will actually form a negative ion, or an anion. So if I take that over to my workspace, basically that would mean that the formula for the nitride ion is N for nitrogen, and then a charge of 3 minus. Okay, since again it has to gain 3 electrons. Now at this point, what I would need to do in order to balance the charges for the ions is to cross over the charges. So this 3, that's currently the charge for the nitrogen, will be brought down to be the subscript for the magnesium. Similarly, this 2, that's currently the charge for the magnesium, is going to cross over and be brought down to be the subscript for the nitrogen. So that my finished formula should be Mg3N2. Okay, let's do another one. Let's actually do calcium fluoride. Okay, now if I want to write the formula for calcium, then if I find it in the periodic table, calcium is right here. Okay, and its nearest noble gas would be argon. Again, similar to the last example, calcium is in group 2, so that means it also has 2 valence electrons. Argon is in group 18, which means it has 8 valence electrons. If calcium is going to get the same 8 valence electron configuration as argon, then that means it would need to lose its 2 valence electrons so that it ends up with the 8 valence electrons in the configuration of argon. And so once again, since we are losing 2 valence electrons, then basically we're going to form an ion that is positive. And since we're losing 2 electrons, then the charge on calcium would be calcium 2+. If I locate fluorine in the periodic table, then fluorine is right here in the periodic table, and its closest noble gas is right next door. Again, once again, it's neon. If I think back to my rules for finding the number of valence electrons for main group elements, since fluorine's in group 17, then it has 7 valence electrons, while neon, once again, has 8. If fluorine's going to get the same number of valence electrons as neon, then basically it would have to gain 1 more valence electron. And so if it does that, then it'll actually end up with the 8 valence electrons that neon has. So that would mean that the formula for the fluoride ion would be F minus, just a single negative charge, because we're only gaining 1 valence electron. And so once again, I'm going to do my crossing over. Now keep in mind, when we write charges, we don't write a charge of 1 minus. Much like in math class, 1 is understood. So if you see a sign all by itself, then that's 1 understood. This 1 understood is going to cross over and become the subscript for calcium, and then this 2 that's presently in the charge for calcium will be crossed over to become the subscript for fluorine, so that my formula should end up being CaF2. Okay, let's try one more. Let's try potassium phosphide. So if I go into my periodic table and I locate potassium, potassium is here. Okay, in group 1, so that means that it has 1 valence electron. Its closest noble gas is argon. And so, once again, argon being in group 18, it has 8 valence electrons. If potassium is going to get the same 8 valence electron configuration as argon, then it should lose the 1 valence electron it has. So, since potassium loses 1 valence electron, then the formula for its ion, for its cation, should be K+. If I locate phosphorus in the periodic table, well, phosphorus is right here. Okay, its closest noble gas is argon. And much like nitrogen above it, basically since it's in group 15, then it has 5 valence electrons. Argon, once again, has 8. So if phosphorus is going to get the same valence electron configuration as argon, then it should gain 3 valence electrons. And so since it gains 3 valence electrons, then phosphorus, when it forms the phosphide ion, will have a 3- charge. And again, now we're at the point where we need to cross the charges over. And when we do that, then we get K3P as our finalized formula. Okay, now not only will we have to actually write formulas given the compound names, but we're also going to have to do the reverse. If I'm given a formula, then basically I would have to then go and be able to piece together the name from the formula that I see. So if I do that, it helps if I break up the compound back into the ions that has made up the compound. All right, so if I take a look at this first compound right here, these ions should be potassium with a plus charge and chlorine with a minus charge. Okay, now the way I can figure that out is because notice that each subscript is 1 understood. Also, if I check the periodic table, here's potassium, and we've worked out the formula for potassium ion before. It would have to lose 1 valence electron, so that's why the charge for potassium should be +1 or just K+. And here's chlorine in the periodic table. Basically, again, it has 7 valence electrons. If it wants the 8 valence electrons of its nearest noble gas, or argon, then it should gain 1 valence electron. So basically that means that the Cl ion should then have a charge of -1. And then I would just name each ion individually, thinking back to what we learned in the previous tutorial. So K plus would just be potassium, and Cl minus should just be chloride. Okay, let's try the next one. So here, again, I'm going to uncross my charges. This 2, that's the subscript for lithium, that's going to become the charge for oxygen. And in general, when we write these formulas, that part of the formula that's written on the right, so for example right here, the oxygen's written on the right side of the formula, so that means it's going to be a negative ion, and since the subscript is a 2 for the lithium, that had to have come from the charge of oxygen. So oxygen should be O2 minus, and lithium should be lithium plus because there's a subscript of 1 understood next to the oxygen. And so I would name each of these ions individually. Li plus is lithium, and O2 minus is oxide. Now, even though it's not included here, I'm going to add another one just to make sure you guys are careful. Here's a formula for a compound where you might be tempted to think that this is composed of magnesium plus ions and S minus ions, but technically that's not really true. Basically, if we look at the periodic table, here's magnesium. Again, we've worked through the formula for the magnesium ion before. Basically, it has 2 valence electrons since it's in group 2, so it would have to lose its 2 valence electrons to get the configuration of neon. So magnesium ion has a 2 plus charge. Similarly, if I take a look at sulfur in the periodic table, notice that it happens to be in group 16, so it has 6 valence electrons. If it's going to get the same valence electron configuration as argon, then it's going to need to gain 2 valence electrons. So because of that, then that means that the formula for sulfur in its ionic form, or the sulfide ion, should be S2 minus. Okay? But notice what happens if I cross these over to create my subscripts, then I get Mg2S2. And much like in math class, when we have a common factor throughout all of the terms in an equation, then we usually factor it out and reduce. It's the same idea here. Since each of these subscripts is 2, then I can simplify this formula by reducing by a factor of 2 to get Mgs. And I would name this compound, Mg2 plus is the magnesium ion, and the formula for S2 minus, or the name for S2 minus, should be sulfide. So this should be magnesium sulfide. Okay, let's do one more. All right, let's do this one. So again, if I uncross my charges, I get Ca2 plus because this subscript 2 will become the charge for the calcium. Notice the calcium has a subscript of 1 understood, so basically that means that the ion formed from bromine has a -1 charge. If we verify in the periodic table, calcium, once again in group 2, it would have to lose 2 valence electrons to get the same valence electron configuration as argon. If I take a look at bromine, bromine in the periodic table is right here. Notice that it would have 7 valence electrons, and krypton would have 8 valence electrons. So to get from 7 valence electrons to 8, I would need to add 1 valence electron. So that means that for bromine, basically when it's in its ionic form, it should have a -1 charge, just like I predicted. If I name each individual ion, then this should be calcium bromide. Okay, so work on the follow-up assignment. There are a few of these that you can do. Again, if you have any questions, email or speak to me in class, and I'll see you guys tomorrow.